Hi, welcome to Software Testing from Scratch, brought to you by Eduonics. This is Chapter 1, Video number 2, What to Test and How to Test It. So we're already halfway through the topics of this chapter. Next we have operating the test system, observing it, evaluating the test results, and reporting them. So, operating the test system. Usually for the duration of the test, the test system will be the QA's baby. If they've got any sense, they wouldn't let anybody else near it through fear of contaminating it. Ideally, it has to be set up the way that you want it to, and there should also be some kind of record of who's going to be using it as well. You have to name the testers, you have to name what roles they're going to have, and when they're going to be working on it. And not only does that ensure that you're not going to be tripping over each other, but it also ensures that if any changes are made, there's a good chance you'll already know who's made them, and it makes regression that much easier as well. And if there is only one test system, chances are different members of the team will be performing different tests at the same time, which is fine, providing it's just your average kind of user tests that wouldn't really impact the hardware in any way. But in the case of load testing, this is where it starts to get a bit more complicated. And as I mentioned previously, it's all fair and good saying that the system is performing as it should with one user on. However, what if there's only two users on, but one of them is performing a load test, which is causing maximum CPU utilization, maximum RAM utilization? It's important that everybody know when load tests are being performed. I'm not saying that you should stop all tests whilst the load tests are being performed, because of course it is good to see how they perform under load as well, but there should be a caveat somewhere in your results to say that these are the results I observed. However, this was when another member of the team was also performing a load test on the system. It's also very important to know when these tests are being scheduled, because if you are under the impression that your results are appearing very slowly because you think the system's under load and it's not, then you have an issue. And next we have my personal favourite form of testing, destructive testing, where you try and break something. It's not usually done too much in the average QA environment. It's usually on the security side of it, trying to cause a denial of service for the actual system. However, you may find if something isn't coded properly when you perform your load test, it may actually turn into a destructive test and break the system. Again, this is why it's so important to have a clear plan on how you can back the system up and regress it to before you cause the destructive tests, just so you don't cause any kind of impact on scheduling for the rest of the testing team. This is a pretty clear-cut definition of what destructive testing is. Destructive software testing is a type of software testing which attempts to cause a piece of software to fail in an uncontrolled manner in order to test its robustness. It's also known as failover and recovery testing. Destructive testing doesn't necessarily mean you're expecting the thing to go up in smoke. It may just be that the web server, if you're testing a web application, would freeze. It may be that it would require a service to be rebooted. Just anything that causes a denial of service for what the application was did for, really. It's very important to monitor your hardware as well as the software. The effect the software has on the hardware is just as important as the functionality of the software itself. If a piece of code performs perfectly, it doesn't matter if the server will only last 20 minutes because of high utilization and temperature issues. Because in reality, in a production environment, only lasting 20 minutes would be completely useless. Which I guess is where this fault-free running time comes into it. It's definitely a good idea to have maybe 24-48 hours worth of fault-free running for your software under test before it goes out to the wider world. If you perform a test case and it only takes you 4 hours and the software crashes after 6 hours, the fault won't be picked up, yet that is definitely something that should have been picked up within the QA environment. It may be that this kind of thing wouldn't be picked up in the real world until it was beta tested, it was actually in situ, in which case it would be very expensive to fix and probably too late by then anyway. A fantastic way of doing this is to pay a student minimum wage and make them sit in front of the system and monitor it. Or alternatively, you could pay for some kind of monitoring software. Usually any kind of monitoring software that the system administration team would use to monitor their network would do. Chances are it will look at the individual hardware elements of the kit. It will trend things. It will alert you if there's a problem, and it also lets you look back over the last X amount of time just to see if there's any discrepancies in the way it's been performing. For instance, ideally, if a test, as I say, only takes 4 hours and you're running this fault-free running time for 24 hours, the system should be idle for the other 20, providing there's no other background processes running. If you were seeing high utilization, 7-8 hours after you finish your testing, then that's definitely something to investigate. I guess the best example would be if a system was designed to do a self-backup at midnight every night, and it used something like log rotate or rsync or something like that, and you weren't testing within that period, you wouldn't catch any issues that would occur with those two processes. I mean, obviously you want to try and script some tests to run around the same time as these, just to make sure they don't cause any user problems, but at the same time, this system monitoring tool would also look at those individual processes and make sure that they themselves weren't causing any issues with the system. Now, when you're evaluating the test results, it's very important to consult the initial requirements to ensure the results are exactly what was expected. If the results have been met, however, you're not happy with them, or if you don't think things are working as they should, it's far better to try and escalate an issue to the development team than it is to pass the test. That may really be a failure. Even if something is performing as expected, but even if you have a little inkling in the back of your head that there might be something wrong, you should investigate it. You shouldn't just pass it, just because it might be an extra 10 minutes of investigation work for you or somebody else. The whole point of test is to be innovative and try and find these problems. I mean, a lot of tests will also have caveats associated with the results. For instance, if you're testing 3G coverage in a certain area, a caveat or warning or proviso may be for a specific condition to say that, yes, we're testing the 3G reception in this area, however we were aware that there was also 150 people connected to the same cell tower. The weather was also atrocious, it was a thunderstorm. However, these are the results. It may be that they have to be repeated in perfect conditions, but it's always better, if you're going to submit any test results, to have a caveat to cover your own back. It would also make the management team a lot more informed about the situation, and then it could be up to them if things needed retesting or if they were going to accept your results.